Welcome to Coding Fab. In this series, we'll learn Python by building small practical projects from scratch. Each project is designed to help you understand core Python syntax and fundamentals step by step. We'll cover things like variables, input, conditions, loops, data structures, and functions, all through real examples. If you're new to Python or want to strengthen your foundation, this series will help you build confidence as you code. Let's get started. Here's a quick overview of what we'll build in this project series. We'll start with very simple projects like greeting and personal info form, where the main focus is learning how to use input and interact with users. These projects help you get comfortable with how programs receive data. Next, we move into basic logic with projects like even or odd checker and grade calculator. Here you'll practice decision making using if, elif, and else, along with simple operators like modulo. Then we'll work with Python data structures. Projects like the shopping list apps, coordinates tracker, shopping list cleaner, and inventory tracker will help you understand lists, tuples, sets, and dictionaries, and how to use them in real scenarios. After that, we introduce functions and classes. Projects such as Simple Calculator, Contact Book, and Employee Management System will show you how to organize code using functions, classes, and even inheritance. We'll also cover error handling and file operations. In projects like the BMI Calculator and Notes app, you'll learn how to handle errors safely and lead from or write to files. As we progress, you'll start using Python's built-in modules. Games and utilities like guess number, countdown timer, age calculator, and file lister will introduce modules such as random, time, datetime, and OS. Toward the end, we'll work on more practical automation and real-world apps. Projects like Attendance Tracker, Settings Manager, Random Joke app, and Weather Checker app will teach you how to work with CSV files, JSON settings, file paths, and even external APIs. By completing these projects, you won't just learn Python syntax, you'll understand how each concept is used in real applications. Okay, let's start building and grow your skills one project at a time. In this project, we will build a simple greeting app that asks for the user's name and then displays a friendly message back to them. It's a great first step into interactive programming because it shows how a program can respond directly to what a user types. This program's goal is straightforward. It takes a name from the user and prints a personalized greeting. You'll see how easy it is to make Python talk back to you, which is one of the most satisfying things for beginners. When the program runs, it asks, "What is your name?" If the user types Tom, the program responds with, "Hello, Tom." You can try it with your own name to see the output change instantly. Along the way, you'll practice key Python concepts such as using the input function to lead information from the user, the print function to display output, and string concatenation to combine text. By the end of this lesson, you'll see how a few lines of Python can create a personalized experience. Try it yourself, experiment with different inputs, and notice how the program reacts. Next, we'll walk through a step-by-step example of building this app so you can follow along and code it yourself. Okay, let's take a look at them one by one. First, the program begins by defining a main function. This is like creating a box to hold all the main steps of the app. It keeps things organized and makes it easier to reuse later. Inside that main function, the program asks the user for their name. It does this by showing a prompt on the screen and waiting for the user to type something. Whatever is typed gets stored in a variable, so the program can use it later. A helpful beginner tip is that you can also clean up any extra spaces from the user's input if you want it to look neat. Next, the program displays a greeting message back to the user using the name they typed. It combines a fixed piece of text with the user's name to make the message personal. This is your first experience with outputting text that changes based on input. Another common way to do this in Python is by using a modern string format called fstrings, which makes the message cleaner and easier to lead. After that, the script includes a standard Python check to see if the file is being run directly. This means the main part of the program will only run when you actually execute this file, not when you import it from somewhere else. Finally, the program calls the main function to start running everything. So in simple terms, the app defines the steps, asks for a name, prints a greeting, and only runs automatically when you execute it. It's a quick but powerful introduction to how input, output, and functions work together. Let's quickly run through how it looks in the terminal. The program asks, "What is your name?" If you type Tom, the computer responds, "Hello, Tom." This project might look simple, but it introduces you to 3 essential programming skills: taking input from the user, storing data in variables, and displaying output back to the user. These are the building blocks for almost everything you'll do in Python. That's it for this project. We built a simple and interactive Python program that greets the user by name. It's a small app, but it shows how you can make your code respond to what someone types in real time. Along the way, you've practiced some of Python's most important basics. You learned how to ask for input from the user, how to store that input in a variable, and how to display a personalized message back to them. You also saw how to organize your code inside a function and control when the program actually runs. You've now taken another step in learning how to create interactive programs. Try changing the prompt or the greeting to make it your own. In the next lesson, we'll go through another example step by step so you can keep building your skills. In this project, we're going to build a simple personal info form. This program will ask the user for some basic personal details, specifically their name, age, and favorite color, and then display that information back in a clear, structured format. It's a great way to practice working with input and output in Python. When the program runs, it starts by showing a title and then asks the user for their name, age, and favorite color one by one. For example, if the user types Tom for the name, 20 for the age, and red for the favorite color, the program will print out a neat summary that says name, Tom, age 20, favorite color red. This flow helps you see how a program collects information and then displays it back. While creating this app, you'll practice using the input function to collect data from the user, variables to store that data, and the print function to display results. You'll also get a taste of basic string formatting to make the output look clean and easy to read. These are essential building blocks in Python. Once you're comfortable with them, you can build bigger, more interactive programs with confidence. By the end of this lesson, you'll see how just a few lines of code can gather multiple pieces of information and present them nicely. In the next part, we'll walk through the program step by step so you can code along and understand exactly how it works. Okay, let's take a look at them one by one. First, the program begins by defining a main function. This is like creating a box that holds all the steps of your app. By placing the instructions inside a function, your code stays organized and you can reuse it or import it without running it automatically. Inside that main function, the very first thing it does is display a title message on the screen. This gives the user a clear signal that they're about to fill in their personal information. Next, the program asks for the user's name. It shows a prompt and waits for the user to type their answer. Whatever the user types gets saved into a variable. This is your first piece of input. Then it asks for the user's age. Again, the program pauses and waits for the user to type a response. That response is stored in another variable. At this point, you've learned how to collect more than one piece of information in a single run. After that, the program asks for the user's favorite color. Just like before, the answer is saved into a variable. This shows you how easy it is to gather multiple inputs from the user. A helpful tip is that you can add strip to each input to clean up accidental spaces or convert the age into an integer if you plan to do math with it later. Once all the information is collected, the program prints a header to show that it's about to display the results. Then it prints each piece of information with a label so the output is neat and easy to read. This is where string formatting comes in handy. You can format your output so it looks clear and consistent. Finally, outside the function, the script checks whether it's being run directly. If it is, it calls the main function to start everything. This check is a standard Python practice, so your code doesn't run automatically when it's imported into another file. That's the entire flow. Define a function, show a title, gather inputs, display the information in a structured way, and run the function only when appropriate. It's a simple project, but it introduces you to user input, storing data in variables, printing results, and keeping your code organized for future projects. Let's quickly run through how it looks. When you start the program, a title message appears on the screen telling you that you're about to fill in a personal info form. The program then asks for your name and waits for you to type it in. For example, you might type Tom and press enter. Right after that, the program asks for your age. You type 20 and press enter. It then asks for your favorite color. You type red and press enter. Once you've answered all the questions, the program clears a line and displays a neat summary of the information you just entered. It shows a small header saying that it's your info, and then lists your name, age, and favorite color on separate lines in a clean, readable format. So in one quick run, you see the program ask 3 questions one by one, you type your answers, and it instantly prints back a tidy summary of everything you entered. That's it for this project. We built a small but powerful Python program that collects personal information from the user and then displays it back in a clean format. It's a simple way to practice making your code interact directly with someone typing on the screen. Along the way, you've learned some key Python skills. You practiced using the input function to gather information from the user, storing that information in variables, and using the print function to display it back in a structured way. You also saw how string formatting can make your output more readable, and how wrapping your code inside a function keeps it organized. This project is a great first step toward building interactive programs. Try changing the prompts or adding more questions to make it your own. In the next lesson, we'll walk through another example step by step so you can keep building your skills with Python. In this project, we're going to build an even or odd checker. This program asks the user for an integer, checks whether the number is even or odd, and then displays the result in a clear way. It's a simple but powerful example of how Python can make decisions based on the data you give it. When you run the program, it starts by showing a title message so you know what's about to happen. It then prompts you to enter an integer. For example, if you type 3 and press enter, the program quickly responds with 3 is odd. If you type 4 instead, it will say 4 is even. This shows how the program takes your input, performs a check, and gives you an instant result. While working through this app, you'll learn how Python collects data from the user with the input function, converts it into a number using int, and uses conditional statements like if and else to make decisions. You'll also practice using the modulo operator to test for even or odd numbers, and the print function to display the results clearly. These key concepts, input, int conversion, if-else statements, modulo, and print, are essential building blocks for writing programs that react to user input and apply logic. By completing this project, you're taking a big step toward writing interactive Python scripts that make decisions. Try experimenting by entering different numbers or adding your own twist to the output message. In the next step, we'll walk through the code step by step so you can see exactly how it works and build your confidence. Okay, let's take a look at them one by one. The program begins by defining a main function that will hold all the logic. Starting with a function keeps things tidy and makes the script easier to reuse later. Inside that function, the first action is to print a short title so the user immediately knows what the tool does. Next, the program prompts the user to enter an integer and pauses, waiting for input from the keyboard. Whatever the user types is then converted from text into a real integer so that math can be performed on it. A helpful tip, if you ever want to make this more robust, you can validate the input with a try-except block to catch non-numeric entries. After capturing the number, the program decides whether it's even or odd. It does this with the modulo operator, which gives the remainder after division. If dividing the number by 2 leaves a remainder of 0, the number is even, otherwise it's odd. Based on that check, the script prints a clear message stating the result, using string interpolation to include the exact number the user entered. Finally, at the bottom of the file, there's the standard entry point check that asks, is this file being run directly? If the answer is yes, the program calls the main function to execute everything. And that's the full flow. Organize the work in a main function, greet the user, lead and convert their input, use a small piece of math to make a decision, and print a readable result, only running the program when the file is executed directly. Let's quickly run through how it looks. When the program starts, it first prints a short title so you know what the app is about. Right after that, it asks you to enter an integer and waits for your input. Suppose you type in the number 3 and press enter. The program immediately checks whether that number is even or odd. Since 3 leaves a remainder when divided by 2, the program responds with a message that clearly says 3 is odd. If instead you type in the number 4 and press enter, the program runs the same check. This time, because 4 divides evenly by 2, the program replies with 4 is even. So the flow is simple and clear. You see a title, you type a number, and the program instantly gives you the correct result based on that number. That's it for this project. We created a simple Python program that checks whether a number entered by the user is even or odd. It's a small but powerful way to see how Python can take what someone types, make a decision, and then display a clear result. Along the way, you've practiced some key Python concepts. Asking for input from the user, converting that input into an integer so you can do calculations, using the modulo operator to test whether a number divides evenly by 2, and applying if and else statements to make decisions. You also use the print function to display your results clearly. This project gives you a foundation for building more interactive and logical programs. Try experimenting by entering different numbers or even changing the messages to make them your own. Great work today. See you in the next lesson. In this project, we're going to build a shopping list app. This program lets you add items to a shopping list, view the list with numbered items, and quit the program when you're done. It's a great way to learn how to make your Python code interactive and dynamic. When you run the program, it greets you with a title and then shows a simple menu. For example, you might choose option 1 and type apple, and the program will confirm that apple has been added to the list. You can then add orange the same way. If you choose option 2, it displays your shopping list neatly with numbers next to each item. And when you're finished, selecting option 0 exits the program with a goodbye message. This flow gives you an instant feel for how a simple menu-driven program works. While creating this app, you'll work with Python's input function to lead what the user types, a while loop to keep the menu running until the user quits, and a list to store all the items added. You'll also practice using if, elif, else statements to respond to the different menu choices. In the next step, we'll go through the code line by line so you can follow along and build your own version confidently. Let's begin by setting up the very first step of our shopping list app. Right now, instead of writing the whole program at once, we're only creating a structure or template. At the top, we define a main function. It prints the title Shopping List App so the user knows what program is running. We also create an empty list called Shopping List that we'll use later to store items. Inside a while true loop, the program shows a menu with 3 options: Add Item, View List, and Quit. This loop keeps repeating until the user chooses to exit. When the user types a choice, the program checks it with if and elif statements. For now, each option just prints a placeholder message like logic for add item or logic for view list. These placeholders mark the spots where we'll add the real code later. There's also an else block at the end to catch any invalid input. Finally, at the bottom, it tells Python to run our main function when this file is executed. This is just our skeleton. In the next steps, we'll go back to each placeholder and write the actual logic for adding items, viewing them, and quitting. Now that we've built the basic skeleton of our shopping list app, let's walk through how we're starting to add logic to it. Look at the code on the left. We're still inside the same while true loop, but this time, instead of just printing placeholders, we're starting to fill in real behavior for each menu option. When the user chooses option 1, the program asks them to type in an item. That item is then added to our shopping list using the list_append method, and we confirm by printing a message back to the user. When the user chooses option 2, the program checks whether the list is empty using len equals 0. If it is, it prints a simple "your shopping list is empty." Otherwise, it loops through the list and displays each item with a number next to it. Here we're using range and len together to count through the items, then printing the number and the item name. When the user chooses option 0, the program says goodbye and uses break to exit the loop. That's how we end the program. And finally, if the user types anything else, the else block prints an error message and the menu appears again. Keys we're focusing on in this lesson are list_append for adding new data to a list, len to check how many items are in a list, for in and range to loop through items with numbers, and break to stop the loop when the user wants to quit. Let's quickly run through how it looks. When you start the program, the title Shopping List App appears on the screen, followed by a simple menu asking you to choose an option. You type 1 to add an item. The program asks you to enter an item to add, and you type apple. It then confirms by printing that apple has been added to the list. The menu appears again. You type 1 once more to add another item. The program again asks for an item, and this time you type orange. It confirms that orange has been added to the list. The menu comes back. Now you type 2 to view the list. The program prints out your shopping list and shows the numbered items underneath, with apple on the first line and orange on the second line. Finally, the menu appears again. You type 0 to quit. The program says goodbye and ends. This is how the app behaves from start to finish, showing you clearly what happens when you add items, view the list, and exit. That's it for this project. We've just built a simple Python program that lets you create and view your own shopping list. It's designed to show how you can interact with a user, store information, and display it back in a clear way. This project introduced you to some of Python's core concepts: storing data in a list, adding items with append, checking if the list is empty using len, looping through the list with a for loop and range to show numbered items, and using break to exit a loop when the user chooses to quit. Great work! You've seen how a simple structure can turn into a working app. Try experimenting by adding new features on your own, and I'll see you in the next lesson. In this project, we're building on our previous shopping list app and adding a new feature: the ability to remove items from the list. This means you can now not only add and view your items, but also take things off the list whenever you want. This program starts by showing a simple menu with 4 options. You can add an item, view your current list, remove an item, or quit the app. For example, when the program runs, you might first choose one to add an item and type apple. If you decide you no longer need apple, you can choose 3 to remove it, and the program will confirm it's gone. Finally, you can select 0 to quit, and the app ends politely. Along the way, you're practicing key Python concepts. You're using input to get user input, storing data in a list, and working with list append and list remove to manage the items. By adding this new remove feature, you're learning how to extend a program step by step instead of building everything at once. This approach makes it easier to understand what's going on. In the next step, we'll walk through the code example together so you can see exactly how each part works. Okay, let's add a remove option to the shopping list app. First of all, let's add a new option, remove item. When the user selects option 3 from the menu, the program first checks if the shopping list is empty by using len. This prevents the app from trying to remove something when there's nothing in the list. If it's empty, the program simply says there's nothing to remove. If there are items in the list, the program asks the user to type the name of the item they want to remove. Before actually removing it, the program uses the if item in shopping list check to see whether the item exists. This is important so the app doesn't crash or confuse the user by trying to remove something that isn't there. If the item does exist, the program calls shopping list remove to delete it. This built-in list method removes the first matching item from the list. After that, it prints a message confirming that the item has been removed. If the item isn't found, it politely tells the user that it couldn't find the item. This feature shows how you can combine len to check the size of a list, if in to see whether a value exists, and list remove to take that value out. Together, these three tools give you full control over adding and removing items safely. Next, let's see how it works. Let's quickly run through how it looks. When you start the program, it shows the title Shopping List App at the top and then displays a menu with options to add an item, view the list, remove an item, or quit. You type 1 to choose the add option. The program asks you to enter an item to add and you type apple. It confirms by printing that apple has been added to the list. The menu appears again. This time you type 3 to choose the remove option. The program asks you to enter the item to remove and you type apple. It confirms that apple has been removed from the list. The menu comes back once more, ready for the next action. This shows how the new remove feature works step by step. First, adding an item, then taking it off the list while keeping everything clear and simple. Let's see what happens if you try to remove something that isn't in the list. After you've added apple by choosing option 1, the menu appears again. This time you type 3 to choose the remove option. The program asks you to enter the item to remove and you type orange. Since orange isn't in the shopping list, the program checks with the if-in condition, realizes it can't find it, and prints a message telling you that orange is not found in the list. The menu then appears again, ready for your next action. This shows how the app gives clear feedback when you try to remove an item that doesn't exist, keeping the experience friendly and preventing mistakes. Let's see what happens if you try to remove something from the empty list. You type 3 right away to choose the remove option. Because nothing has been added yet, the program checks the length of the list with len and sees that it's 0. It then prints a friendly message telling you that your list is empty and there's nothing to remove. The menu appears again, ready for you to choose another action. This shows how the app safely handles the remove option when the list is empty, giving clear feedback instead of an error. That's it for this project. We built a simple Python program that manages a shopping list. It lets you add items, view everything you've added, and now even remove items you no longer want. It's a small but practical app that shows how Python can handle everyday tasks. This project demonstrates several key Python concepts: using input to lead user input, storing data in a list, adding and removing items with list append and list remove, checking if a list is empty with len, looping with while true to keep the program running, using if elif else to handle different menu choices, and displaying items with a for loop and range. Great work. You've seen how to expand a simple program step by step and manage user input safely. Try experimenting with adding more features yourself, and I'll see you in the next lesson. In this project, we're going to build something that helps us understand how far apart 2 points are. Imagine you're planning a trip from New York to London, just like the map on the slide shows. The dotted line represents the journey between the two cities. Behind the scenes, this distance can be calculated using a simple mathematical formula. Here you can see 2 points marked as x1, y1 and x2, y2. This is how we represent locations in a coordinate system. The formula below shows how to calculate the straight line distance between them. We're going to make a small Python program that works just like this. You'll be able to enter 2 points, and the program will tell you the distance between them. It's a fun way to see how math and coding come together to solve a real-world problem, like measuring the distance between cities on a map. Now let's zoom in on what we're actually going to build. Our project is called Coordinates Tracker. It's a simple console app, but it pulls together several core Python ideas in one place. In this app, you'll be able to store points as x and y coordinates, view everything you've saved, and even calculate the straight line distance between any 2 points you choose. Think of it like a mini version of plotting places on a map and then measuring the space between them. On the left side, you can see how the program behaves when it runs. You start with a clear menu of options. You add a point by typing in its x and y values. You can add as many as you like, and at any time choose option 2 to view them. When you're ready, you pick option 3 to calculate a distance. The program shows you a numbered list of your saved points, so you can easily choose 2, and then it instantly calculates and displays the distance. These are the key skills you'll practice as you create this. You'll learn how to accept user input, store data in a list, use tuples to keep x and y values together, loop through your data with while and for, and control the flow with if-elif-else statements. You'll also get to apply a bit of basic math to make your program actually do something useful. To calculate the distance, you can use this formula. Take the difference between the x values and square it. Do the same thing for y values. Then add them together and take the square root to work out the straight line distance between the 2 points. By the end of this project, you'll have built a working program from scratch and seen how these Python concepts fit together to solve a real problem. Now that we've seen what the program does, let's start by writing the entire structure of our code. Rather than jumping straight into the full logic, we'll first create a simple template or skeleton. This helps you see the flow of the program and makes it easier to add each piece of logic step by step. We begin with a main function that prints a title and creates an empty list called coordinates to store our data. Inside a while true loop, we display a menu with options for the user. We then lead their choice using input and use an if-elif-else block to decide what should happen. In the next step, we'll start filling in the real logic for each menu option to bring the app to life. Let's start by filling in the logic for option 1, which adds a coordinate. When the user chooses this option, we first ask them to type in the x value and store it as a floating point number using float input. We do the same for the y value. Next, we group these two values together into a single point by creating a tuple. Using a tuple is helpful here because it keeps the x and y values together as one item. We then add this point to our coordinates list using coordinates append point. This way, every time the user enters a new point, it gets stored in our list. Finally, we give the user feedback by printing out a message that says which point was added. This makes the program interactive and lets them confirm their input. By writing this block of code, we've completed the logic for option 1. In the next step, we'll work on the code to display all saved coordinates. Now let's fill in the logic for option 2, which lets the user view all the coordinates they've saved. When the user chooses this option, the program first checks if our coordinates list is empty using if not coordinates. If the list is empty, it prints no coordinates saved yet. This gives clear feedback so the user knows there's nothing to show. If the list isn't empty, we go into the else block. Here, we print save coordinates to introduce the list of points. Then we use a for loop with enumerate coordinates start1 to go through each point. Enumerate is useful because it gives us both the position number and the actual point at the same time. Inside the loop, we unpack each point's x and y values and print them in an easy-to-read format. This way, the user sees a numbered list of all their stored coordinates. By writing this block of code, we've completed the logic for option 2. In the next step, we'll handle the code that calculates the distance between two chosen points. Now let's add the logic for option 3, which calculates the distance between two saved points. The first thing our code does is check whether there are at least 2 points stored using if. If there aren't enough points, we print a message telling the user they need at least 2 points to calculate a distance. If there are 2 or more points, we go into the else block. Here, we display a numbered list of all the saved coordinates using a for loop with enumerate coordinates start1. This gives the user an easy way to see which points are available and their numbers. Next, we ask the user to choose 2 points by number. We take their input, convert it to an integer, and subtract 1 because list indexes in Python start at 0. We store these choices in I1 and I2. After that, we unpack the chosen coordinates into x1, y1, and x2, y2. Then we apply the distance formula, which calculates the straight line distance between the 2 points. Finally, we print out the result in a clear message showing both points and their distance. Notice the code uses 2f. This is Python's way of formatting numbers. The 2f means format this number as a floating point value with 2 digits after the decimal point. This makes the output neat and easy to read. This completes the logic for option 3. In the next step, you'll see how all the parts work together to make the full program run smoothly. Finally, let's look at what happens when the user chooses to quit or enters an invalid option. If the user enters 0 at the menu, the program runs the code inside elif choice is 0. Here we simply print goodbye and then call break. In Python, break immediately stops the current loop. In this case, it ends the while true loop, so the program finishes and closes gracefully. If the user types something other than 1, 2, 3, or 0, the code goes to the else block. This prints invalid choice. Try again to let the user know their input didn't match any menu option, and then the loop repeats to show the menu again. This small section of code gives your program a clean way to exit and also helps guide users back on track if they make a mistake. With this, you've now explained all the main parts of the coordinates tracker. Let's quickly run through how it looks. When you start the program, a welcoming title appears on the screen along with a simple menu of choices. You pick option 1 to add your first coordinate. The program gently asks you for the x and y values. Let's enter 0. Right away, it lets you know that point has been added. You go back to the menu and pick option 1 again to add another point. Once more, it asks for the x and y values. Let's type 100. It confirms that the point has been added. Now you're curious to see what's stored, so you choose option 2 to view all coordinates. The program prints a clear heading saying saved coordinates, and then shows the 2 points you've entered, neatly numbered so you can tell them apart. It feels like you're building a little list of coordinates right inside the program. Next, we try the distance feature right after adding the points. Since 0, 0 and 100, 100 are already saved, you choose option 3. The program shows the list of saved coordinates with numbers next to each. It then asks you to pick the first point number. You type 1, and then the second point number. You type 2. Instantly, it calculates and prints the distance between each point, showing a clean, nicely formatted result. You can see how easy it is to measure the space between any 2 points you've saved. Finally, let's check the option 0 from the menu. The program politely prints goodbye and closes. This gives you a smooth way to exit after you've finished working with your coordinates. By following these steps, learners can clearly see how the program flows, from adding points to viewing them, to calculating a distance, and finally quitting the app. That's it for this project. We built a small but practical app called Coordinates Tracker that lets you add points, view them, and calculate the distance between any two. It's a simple way to practice how Python can store and work with data you enter. Along the way, you've used several key Python concepts. You practiced taking user input with input, storing data in a list, grouping x and y values in a tuple, using loops like while and for to repeat actions, and applying if-elif-else statements to control the flow of your program. You also formatted your output neatly, so the results are easy to read. Great job! Try adding your own features like naming your points or saving them to a file. See you in the next lesson where we'll build on these skills even further. Now let's zoom in on what we're actually going to build. This project is called Inventory Tracker, and it's a simple but powerful console app that helps you keep track of items. You can add new items with quantities, remove items you no longer need, and view everything you currently have in one place. When you run the program, it greets you with a menu showing 4 options. For example, you might choose option 1, type apple and 1, and the app will confirm that 1 apple have been added. If you choose option 3, it will display your current inventory, showing each item and its quantity clearly on the screen. Along the way, you'll get hands-on practice with some of Python's most important building blocks. Using input to collect data from the user, storing and updating that data in dictionaries, controlling the flow with if-elif-else statements, and using loops to make the program run continuously. You will also see how small but useful string methods like strip and lower help clean up the data you collect. By the end, you'll not only have a working inventory tracker, but also a solid understanding of how these Python features work together. In the next step, we'll walk through the code line by line so you can see exactly how everything fits together. Okay, let's take a look at the structure of our program. Rather than writing the full working code right away, we're first creating a clear skeleton or template. This template lays out what the program will do at each stage without the detailed logic filled in yet. We start by giving the program a main section where it prints a title so the user knows what app they're running. Then we create an empty dictionary that will eventually store the items and their quantities. This dictionary acts like a digital cupboard where our data will live. Next, we set up a loop so the program keeps running until the user chooses to quit. Inside this loop, we display a simple menu of 4 options: add an item, remove an item, view the inventory, or quit the program. We then use input to capture the user's choice. Inside the loop, we've added if, elif, and else branches. Each branch is a placeholder that prints a short message showing where the real logic will go later. For example, the first branch is where we'll build the add item logic, the second is for removing an item, and the third is for viewing the inventory. If the user chooses to quit, the loop breaks and the program says goodbye. If the user types something outside of 1 to 4, it will display an error message telling them to pick a valid option. This structure is like a roadmap of the full app. It shows the flow and the major steps without being weighed down by all the details. In the next stage, we'll come back to each placeholder one by one and write the actual logic that makes the program work. This step-by-step approach makes it easier to understand and debug while you're learning. Now let's dive into how the actual code for our inventory tracker works. We've already built the structure before, so here we're filling in the real logic step by step. First, option 1. If the user selects option 1, they're asked to type the name of an item. We clean that input with strip and lower so it's consistent. Then we ask for the quantity. We use isDigit to check that the quantity is a number, and int to convert it from text to a real number. Next, we add that item to the inventory. If it already exists, we update its quantity using inventory item plus $QTY. If it's a brand new item, we create it with inventory item $QTY. This shows how dictionaries let you store and update data easily. Later, you'll see how the other options work, removing an item and viewing the full inventory. By combining these small steps, the app becomes a useful tool for keeping track of your items. Now let's look at the part of our code that removes items from the inventory. Up until now, we've been adding things in, but of course we also need a way to take them out when they're no longer needed. Inside our loop, when the user selects option 2, the program asks for the name of the item to remove. We clean up the input the same way as before by stripping spaces and converting it to lowercase so everything stays consistent. Next comes the important check. The program looks inside the dictionary to see if the item exists. If it does, we use the del keyword followed by inventory item to delete that key value pair entirely from our storage. This is how you remove data from a dictionary in Python. After deleting, the program prints a confirmation message so the user knows the item is gone. If the item isn't in the inventory, the program prints item not found. This feedback helps the user understand why nothing happened and prevents errors. This small piece of logic shows how easy it is to manage data inside a dictionary, not just adding and updating, but also deleting. In the next step, we'll move on to viewing the inventory so you can see how everything fits together as a complete working app. Now let's move on to the part of the code that displays everything currently in our inventory. This is the piece that lets the user actually see what's stored. Inside our loop, when the user selects option 3, the program first checks if the inventory dictionary is empty. If it is, it prints a simple message saying inventory is empty. This prevents the program from trying to show something that isn't there. If the inventory isn't empty, the program prints a header to show that we're about to display the current inventory. Then it loops through every item and its quantity using for item, QTI, and inventory items. This is a special way in Python to grab both the key and the value from a dictionary at the same time. Inside the loop, the program prints each item along with its quantity in a neat, readable format. This gives the user a clear picture of what's available at that moment. With this step, our app can now add, remove, and view items, making it a fully functioning inventory tracker. Now we've reached the last part of our code, where we handle quitting the program and managing invalid choices. Inside our loop, when the user selects option 4, the program prints a simple goodbye message and then uses the break keyword. Break tells Python to immediately exit the while loop, which stops the program from running any further. This is a clean way to end an ongoing loop when the user decides they're done. If the user types something that isn't one of the menu options, the program runs the else block. Here we print a friendly message telling them to select a valid option. This gives clear feedback and prevents errors. Finally, at the very bottom, you can see the ifname main line. This ensures that main only runs automatically when this file is executed directly. It's a standard Python practice for structuring programs. With all of these pieces, adding, removing, viewing items, quitting cleanly, and handling mistakes, you now have a complete functioning inventory tracker. In the next part, we'll jump into the demo so you can see exactly how it runs from start to finish. Let's quickly run through how it looks when you actually run the program. The screen first shows the title Inventory Tracker and then displays a menu with 4 options. You type 1 to add an item. The program asks for the item name, you type apple, and then it asks for the quantity, you type 1. The program confirms that apple has been added with quantity 1. Now the menu appears again. This time you choose 2 to remove an item. The program asks for the item name to remove. You type apple and it tells you that apple has been removed from the inventory. Finally, the menu shows up once more. You choose 3 to view the inventory. Since you just removed apple, the program prints inventory is empty. This sequence shows how the app responds step by step to your input adding, removing, and displaying items in a clear and simple way. Let's quickly run through how it looks with a slightly different scenario. This time we're going to test option 3 after adding 2 items to the inventory. First, I start by adding the first item. I choose option 1, type apple as the item name, and enter 1 for the quantity. The program confirms that apple has been added with quantity 1. Next, I add the second item. Again, I choose option 1, type orange as the item name, and enter 2 for the quantity. The program confirms that orange has been added with quantity 2. Now that we have apple and orange in the inventory, let's test option 3. I choose option 3 to view the inventory, and the program shows a header saying current inventory, followed by 1 apple and 2 orange. This makes it clear how you can add multiple items and then check them all at once. Now let's try adding an item that already exists in the inventory to see how the program updates quantities. First, I choose option 1, type apple as the item name, and enter 1 for the quantity. The program confirms that apple has been added with quantity 1. The menu appears again. This time I'm going to add apple once more. I choose option 1, type apple again as the item name, and enter 2 for the quantity. Instead of creating a duplicate entry, the program updates the existing apple and shows the new total quantity as 3. Finally, I choose option 3 to view the inventory. The program displays current inventory and shows 3 apples, confirming that the quantity was successfully updated rather than added as a separate item. This demonstrates how the app keeps your data clean and automatically combines duplicate items. Sometimes users make mistakes while entering data, and our program handles those gracefully. For example, when you choose option 1 to add an item but type something that isn't a number for the quantity, like the word 1 instead of the number 1, the program checks the input with this digit. If it's not a valid number, it prints a clear message saying quantity must be a number and goes back to the menu without crashing. Another situation is when you choose option 2 to remove an item that doesn't exist in the inventory. The program first checks if the item is there. If it isn't, it prints item not found so you know why nothing happened. This gives helpful feedback rather than leaving you guessing. And finally, if you accidentally type an option number that doesn't exist, for example 5 instead of 1, 2, 3, or 4, the program runs the else branch. It prints invalid choice. Please select 1 to 4 and shows the menu again. This prevents errors and keeps the program running smoothly. These small details make the app much more user-friendly and reliable, even when mistakes happen. That's it for this project. You've just built a simple but powerful inventory tracker, a program that helps you add items, update quantities, remove items you no longer need, and view your current inventory all from the console. Along the way, you've practiced some of Python's most important building blocks for beginners. You used input to collect information from the user, dictionaries to store and manage data, loops to keep the program running until you quit, and if-else statements to control what happens depending on your choices. You also saw how small string methods like strip and lower help clean up the input so your data stays consistent. Great work! Take some time to experiment by adding more features or changing the menu to make it your own. See you in the next lesson. Now let's zoom in on what we're actually going to build. Our project is called Shopping List Cleaner. It's a simple but very practical program that takes a messy shopping list and turns it into a neat, organized one. It works by removing duplicate items, converting everything to lowercase so it's consistent, and sorting the list alphabetically so you can quickly see what you need to buy. When you run the program, you'll be asked to enter your shopping items separated by commas. For example, if you type milk, bread, milk, eggs, apples, the program will show you a cleaned list with a total count of items and unique items. This project introduces some very useful Python concepts. We use input to get the list from the user, split to break it apart, set to remove duplicates, sorted to order the items alphabetically, and list comprehensions to clean up and format the data. This is a great beginner project because it shows how just a few lines of Python can take messy data and make it organized. It's also the kind of small program you can use in real life. In the next step, we'll go through the code line by line so you can see exactly how it works and start building it yourself. Okay, let's take a look at them one by one. We start by defining our main function. This is where the program's work happens. Inside it, the very first thing we do is print a title message that says Shopping List Cleaner. This helps the user know what the program is about. Next, we use the input function to ask the user to type their shopping list items, separated by commas. This input is saved into a variable called text. At this point, the data is still just one long string. Then we process the string. We split the text into individual items using the split method with a comma as the separator. This turns the single string into a list of items. We also use a list comprehension here. The general pattern looks like this: square brackets, then an expression, followed by a for loop, and optionally an if condition. It reads almost like plain English. Do this for each item if a certain condition is true. We use a list comprehension to clean up each shopping item. Inside the brackets, we take each item from the split text, apply strip, to remove spaces, apply lower, to make it consistent, and only include it if it's not empty. All of that happens inside one expression. This is powerful because it combines looping, transforming, and filtering in a single line. It keeps your code shorter, easier to lead, and faster to write. After cleaning the items, we want to remove duplicates. For that, we convert the list to a set, which automatically keeps only unique values. Because sets don't have order, we use the sorted function to arrange the items alphabetically. The result is stored as unique underscore items. Now we're ready to show the results. We print a heading for the clean shopping list. We also print how many total items were entered and how many unique items remain after cleaning. This gives the user a quick overview. Finally, we print each item in the cleaned list one by one using a for loop. This is where the user can see their neat, organized shopping list. At the end of the file, there's a small check. This tells Python to run the main function only if the script is run directly, not if it's imported into another program. This is a common Python pattern and a good habit to follow even in small projects. Let's quickly run through how it looks when you actually run the program. First, the program starts by printing a title message saying Shopping List Cleaner, so you know what tool you're using. Then it asks you to enter your shopping list items separated by commas. Let's type in milk bread, milk, eggs, eggs, apples, and press enter. Right after that, the program begins cleaning up your list. It removes any extra spaces, converts everything to lowercase, removes duplicate items, and sorts the list alphabetically. On the screen, you'll see a heading saying Clean Shopping List. It shows that the total items you entered were 6 and the number of unique items is 4. Then it prints your cleaned list, one item per line in order: apples, bread, eggs, milk. This is the full flow the user experiences from start to finish, and it gives instant feedback showing how a messy list can be transformed into a neat, organized one. That's it for this project. In this lesson, we built a simple but practical program called the Shopping List Cleaner. It takes a messy shopping list and turns it into a neat, organized one by cleaning up spaces, making all items lowercase, removing duplicates, and sorting them alphabetically. This project introduced some core Python concepts every beginner should know. You learned how to use input to get information from the user, how to process strings with methods like split, strip, and lower, how to use a set to remove duplicates, and how to sort items with sorted. You also saw how a list comprehension can combine these steps into one clear line. Great work! You've just seen how a few simple Python tools can turn messy data into something useful. See you in the next lesson, where we'll build on these skills with another fun project. Now let's zoom in on what we're actually going to build. This project is called Simple Calculator, and it's a small but powerful program that lets you perform basic math right inside your terminal. You can add, subtract, multiply, or divide numbers without needing a separate calculator app. When you run it, the program greets you with a simple menu of operations to choose from. For example, you might select 3 for multiply, then enter the first number as 1 and the second number as 2. Right after pressing enter, the program instantly returns the result 2. It's that straightforward. Along the way, you'll see how to use key Python features to make this happen. You'll practice writing and calling multiple functions, taking user input with the input function, converting that input into numbers using float, and controlling the flow with if, elif, and else statements. These are the building blocks for almost any Python program. By the end, you'll not only have a working calculator, but also a clear example of how simple pieces of Python fit together to solve real problems. This is a great way to build confidence in writing your own code. In the next step, we'll walk through the code and build this project piece by piece so you can see exactly how it works. First, we're going to build the entire structure of our simple calculator. Rather than jumping straight into writing the complete code, we'll begin by creating a clean template. This template will include the names of our functions, the menu system, and where each piece of logic will go. By doing this, you'll see the full shape of the program before worrying about the actual calculations. We'll start by writing out our 4 basic operations: add, subtract, multiply, and divide as empty functions. Inside each one, we'll just leave a simple placeholder message. This way you know exactly where to put your calculation logic later. Then we'll write our main program. In the main section, we'll show a menu with the choices for add, subtract, multiply, and divide. For now, instead of actually doing the math, we'll just display a message saying something like call add here or ask for numbers here, so you can see the flow. The goal of this first step is to get comfortable with the program's structure, how functions are defined, how the main loop works, how user choices are handled. Once this skeleton is in place, we'll go back and fill in the real logic step by step. That means replacing each placeholder message with real calculations and input handling. By breaking it up like this, you'll have a much easier time understanding where each piece of logic belongs and how the program flows from start to finish. Okay, let's take a look at them one by one. In this slide, we're focusing on creating the functions for our simple calculator. Rather than building the whole program at once, we're breaking it into small, clear pieces. Each piece is a function that performs a single calculation. This approach keeps our code organized and makes it easy to reuse and test each operation separately. At the top, we define the add function. This function takes 2 inputs, a and b, and produces their sum. It's the simplest possible example of a function. You pass values in, it does one thing, and it returns a result. Next comes the subtract function. It also takes 2 numbers, but this time it returns the first minus the second. Both of these functions show how you can clearly express a single task inside its own block. After that, we define the multiply function. Again, the pattern is the same. The function receives 2 numbers and returns their product. By keeping the same style in all 3, you can see the structure repeating, which makes your code predictable and easier to lead. Finally, we get to the divide function. This one introduces a key idea: error handling. Before it tries to divide, it checks if the second number is 0. If it is, the function returns a special message instead of trying to divide, because dividing by 0 would crash the program. This is a very simple but important example of adding safety checks to your code. If the second number is not 0, the function returns the result of the division as expected. By writing these 4 functions first, you now have a solid foundation. Each function is small, clear, and does just one job. Later, you will connect these functions to a menu system in your main program. But for now, this slide shows you the clean building blocks you can rely on. The next is about connecting the calculator's functions to real input from the user. Up until now, we've defined the add, subtract, multiply, and divide functions separately. Here we're showing how to ask the user for numbers, store those numbers, and then call the correct function based on their menu choice. First, we see two lines that ask the user to enter numbers. The input function reads what the user types. Because input always returns text, we wrap it in float so the program converts the text into a real number. Each converted number is stored in a variable. One variable holds the first number and another holds the second. Variables are like boxes that remember the values you'll use later. Next comes a series of if and elif sections. These check which menu option the user picked earlier. If the choice is 1, the program calls the add function with the two numbers as arguments, stores the returned result, and then prints it. If the choice is 2, the same thing happens with the subtract function. Choice 3 runs multiply and choice 4 runs divide. In each case, the function is called with the two values you collected at the top, and the result is displayed to the user. Finally, there's an else at the end. This runs if the user types something that isn't one of the 4 options. In that case, the program simply prints a message saying the choice is invalid. This is a basic form of input validation, making sure the program doesn't break or behave strangely if the user types something unexpected. By combining these pieces, you now have a small but complete flow. You ask for input, you convert it to numbers, you store them in variables, you call the right function depending on the menu choice, and you show the result. This is how the functions you wrote earlier become a working calculator when tied to real input and output. Let's quickly run through how it looks when you actually run the program on the screen. When you start the program, it prints a friendly title saying Simple Calculator, and then shows a small menu with 4 choices: add, subtract, multiply, and divide. The program then asks you to pick an option. If you type 1, the program asks you to enter the first number. You type 1. It then asks for the second number. You type 2. Because you chose option 1, the program calls the add function with those two numbers and prints out the result, which appears as result 3. If you run it again and type 2 at the menu, the program asks for the first number. You type 1. It asks for the second number. You type 2. Because you chose subtract, it prints result -1. If you run it again and choose option 3, it asks for the first number. You type 1. It asks for the second number. You type 2. It calls the multiply function and prints result 2. If you choose option 4, it again asks for two numbers. You type 1, then 2. The divide function runs and prints result 0.5. Finally, if you choose option 4 again, but this time enter 1 and then 0, the program checks for division by 0, and instead of crashing it, prints a clear message saying error, division by 0. This is how the calculator behaves step by step. It shows a menu, takes your inputs, calls the right function, and prints a result or an error message depending on what you entered. That's it for this project. We've just built a simple calculator that makes basic math quick and easy right inside your terminal. You can add, subtract, multiply, or divide numbers with just a few steps, and the program gives you the result instantly. In building this, you've practiced writing and calling multiple functions, taking input from the user, converting that input to numbers, and using if, elif, and else statements to control the program's flow. These are some of the most important skills for any Python beginner. Great work. Try experimenting with the code to add new operations or improve the menu, and see what else you can create. See you in the next lesson. In this project, we're going to build a grade calculator. This program will ask the user to enter a score between 0 and 100, figure out which letter grade that score belongs to, and then display the result clearly on the screen. It follows the grade table here, so each score is matched to the correct letter grade. When you run the program, it starts by showing a title message so you know what's about to happen. It then prompts you to type a score. For example, if you type 80 and press enter, the program instantly responds with "Your grade is B." This smooth flow shows how your input is captured, processed, and turned into a clear output according to the grade table. While creating this app, you'll learn how Python collects data from the user with the input function, converts that input into a number with float, uses variables to store values, and applies if, elif, else statements to make decisions. You'll also practice displaying results with the print function. These key concepts, input, float conversion, variables, if, elif, else, and print, are essential for writing programs that react to user data and apply logic. By finishing this project, you're building a strong foundation for creating interactive programs. Try experimenting by entering different scores or adjusting the grade ranges to make it your own. In the next step, we'll walk through the code line by line so you can see exactly how it works. Okay, let's take a look at them one by one. The program begins by defining a main function. Putting the steps inside a function keeps the code neat and reusable. Inside that function, the first thing it does is print a simple title so the user knows what the tool is about. This gives a clear start to the program. Next, the program asks the user to type a score. As soon as the user enters it, the input is converted from text to a floating point number. Converting it this way allows the program to handle numbers with decimals as well as whole numbers. A useful tip here is that you can add a small check to make sure the score is between 0 and 100, or wrap the conversion in a try-except block to catch non-numeric entries. After getting the score, the program runs a series of conditions to decide which letter grade to give. It checks the highest range first and then works down. Scores of 90 or above get an A, 80 or above a B, 70 or above a C, 60 or above a D, and anything below 60 an F. This sequence matches the grade table shown on the slide and makes sure every score falls into exactly one category. Once the correct grade has been decided, the program prints a clear message showing the result so the user immediately knows their grade. You could later enhance this by adding comments like "excellent work" or "needs improvement" depending on the grade. Finally, at the bottom of the file, the program includes the standard Python entry point check. It asks whether this file is being run directly, and if so, calls the main function to execute everything. This is a common pattern in Python to stop the code from running automatically if it's imported elsewhere. That's the whole flow. Show a title, collect and convert the user's score, decide the correct letter grade based on the grade table, display the result, and only run the program when the file is executed directly. Let's quickly run through how it looks. As soon as you launch the program, a bold title pops up telling you it's the grade calculator, setting the stage for what's about to happen. It then invites you to type in a score, and right after you hit enter, it instantly gives you a letter grade. For example, when you enter 90, it proudly says your grade is A, showing you've hit the top mark. Type 80 next, and it comes back with your grade is B, nudging you into the next band. Enter 70, and you see your grade is C, clearly shifting into the middle range. When you try 60, the program returns your grade is D, showing you're just at the passing edge. And finally, if you put in 50, it responds with your grade is F, clearly marking it as below the threshold. In just a few quick inputs, you see the program move you through all the grade categories, matching the table on the slide. It feels immediate, clear, and gives you an instant sense of how your score translates into a letter grade. That's it for this project. We built a grade calculator that takes a score from the user and instantly tells them the correct letter grade based on the grade table shown on the slide. It's a simple program, but it clearly shows how Python can take input, apply logic, and produce a meaningful result. Along the way, you've practiced essential Python concepts. You used the input function to get information from the user, converted it into a number so calculations work properly, stored it in a variable, and then applied if-else statements to make a decision. You also use the print function to display the final grade clearly. These are the building blocks of programs that can react to user input and apply real logic. Great work! See you in the next lesson. Now let's zoom in on what we're actually going to build. The goal of this program is straightforward. The user enters a password and the program analyzes it step by step. It checks things like length, uppercase letters, lowercase letters, numbers, and symbols. Based on these rules, the program classifies the password as weak, medium, or strong, and then gives clear suggestions on how to improve it. The user can keep testing different passwords in one run, just like a real application. When the program runs, it looks clean and interactive in the terminal. For example, if the user first enters pass, the program immediately shows that the password is weak and explains that it's too short and missing important characters. Next, when the user tries a password, it's still weak, but for slightly different reasons. When they enter a password with an uppercase letter, the strength improves to medium. Then with password 123, it becomes even better. Finally, when they enter password 123 exclamation mark, the program recognizes it as strong and confirms that it meets all the requirements. You can clearly see how each small change affects the result. To build this, we'll use core Python concepts that are essential for beginners. We'll take user input using input, store, and check values using variables, and control the program flow with if, elif, and else. A while loop allows the application to keep running so users can test multiple passwords. We'll also organize our logic into functions and use string methods like isUpper, isLower, and isDigit to analyze each character in the password. In the next step, we'll walk through the coding step by step so you can clearly see how everything fits together. Now let's take a look at the structure of our application and understand how everything is organized before we start writing the actual logic. At the top of the file, you can see several helper function definitions like has uppercase, has lowercase, has digit, and has symbol. Right now, these functions are empty on purpose. Each one has a very clear responsibility. It checks a single rule about the password and returns a result. By separating these checks into small functions, the code becomes easier to lead, easier to test, and much easier to improve later. Next comes the check password strength function. This is the core of the application. Inside this function, we keep track of a score and a feedback list. For each rule, such as password length or character type, we either increase the score or add a message to the feedback list. This design allows us to calculate the strength and collect improvement tips at the same time, instead of mixing everything together. Below that is the main function, which controls how the application runs. This is where the user interaction happens. The program prints a title, asks the user to enter a password, and then calls check password strength to analyze it. A while loop keeps the application running so the user can test multiple passwords without restarting the program. Based on the score, the password is classified as weak, medium, or strong, and any feedback messages are displayed. Finally, the ifName block defines the entry point of the application. This tells Python to run main only when this file is executed directly, which is a best practice you'll see again in larger projects. This structure is intentional. It shows how real Python applications are built by breaking problems into small, focused functions and connecting them together cleanly. Don't worry if some parts feel incomplete right now. That's exactly the point of this step. In the next step, we'll start updating the helper functions one by one and see how they actually check the password characters in a clear and beginner-friendly way. Now let's focus on the helper functions, because these are the building blocks that make the password checker work. Each helper function has one small and clear job. The first function goes through the password character by character and checks whether at least one uppercase letter exists. As soon as it finds one, it returns true. If the loop finishes without finding any uppercase letters, it returns false. The lowercase and digit checks work in exactly the same way. just using different string methods. This consistency is important because once you understand one function, the others feel familiar. For symbols, we define a string that contains allowed special characters. Then we loop through the password again and check whether any character belongs to that symbol list. If it does, we immediately return true. Otherwise, we return false at the end. This shows a very common and useful pattern, looping through data and exiting early when a condition is met. What's important here is not just what these functions do, but how they are written. We're using for loops to inspect each character, string methods like isUpper, isLower, and isDigit to classify characters, and return statements to send results back to the main logic. Each function answers a simple yes or no question, which makes them perfect for reuse. By organizing the code this way, we keep the logic clean and avoid repetition. If we ever want to change the rules, for example by adding new symbols or new conditions, we only need to update one small function instead of the entire program. In the next step, we'll use these helper functions inside the check password strength function and see how they work together to calculate the score and generate feedback for the user. Now let's take a closer look at the heart of the application, the check password strength function. This function is where all the rules come together. At the beginning, we prepare two things. One is a score variable, which starts at 0 and will increase as the password meets each requirement. The other is a feedback list, which will store messages explaining what the user needs to improve. The first check is the password length. If the password is at least 8 characters long, we increase the score by 1. If not, we add a clear message to the feedback list, telling the user to use at least 8 characters. This same pattern repeats for every rule that follows. Next, we check for uppercase letters by calling the helper function we created earlier. If the condition is met, the score goes up. If not, we add a suggestion explaining what's missing. We then repeat this exact logic for lowercase letters, numbers, and symbols. Each rule is simple on its own, but together they create a meaningful evaluation of password strength. What's important here is how readable and structured this logic is. Every rule follows the same flow: check a condition, update the score if it passes, or add feedback if it fails. This makes the function very easy to understand and easy to extend later if we want to add more rules. At the end of the function, we return both the final score and the feedback list. This allows the main function to decide how to label the password as weak, medium, or strong, and also display helpful suggestions to the user. This approach mirrors how real applications work. Instead of stopping at the first failure, we analyze everything and give complete feedback, which makes the program much more user-friendly. In the next step, we'll update the main function and connect everything together, so the results are displayed clearly and the user can interact with the application smoothly. Now let's focus on the updated part inside the main function, specifically the section highlighted here, because this is what turns our logic into clear, user-friendly output. After we calculate the score and determine whether the password is weak, medium, or strong, we check the feedback list. This list contains suggestions collected earlier in the program when the password failed certain rules. If the feedback list is not empty, the program prints a short message letting the user know there are suggestions to improve their password. Then we use a for loop to go through each item in the list one by one. Each suggestion is printed on its own line, which makes the output easy to read and easy to understand. This loop is important because we don't know in advance how many suggestions there will be. Sometimes there might be one, sometimes several, and sometimes none at all. If the feedback list is empty, that means the password passed all the checks. In that case, instead of showing suggestions, the program prints a simple positive message telling the user that their password is strong. This creates a clear and satisfying ending for a successful input. This pattern is very common in real applications. Programs often collect messages during processing and then decide how to display them at the end. In the next step, we'll validate the program by running it with different example inputs and confirming that the output matches our expectations. Now let's validate the application by actually running it with different inputs and confirming that each rule works exactly as intended. First, we start with a very simple password like pass. This input contains only lowercase letters and is too short. As expected, the program classifies it as weak and clearly lists everything that's missing, such as length, uppercase letters, numbers, and symbols. This confirms that the lowercase check alone is not enough to produce a strong password. Next, we try password. This one is longer and meets the minimum length requirement, but it still contains only lowercase letters. The result is still weak, and the suggestions now focus on adding uppercase letters, numbers, and symbols. Then we enter password with uppercase, so the strength improves to medium. The feedback correctly points out what's still missing, such as numbers and symbols. This demonstrates how the score increases step by step as more conditions are satisfied. After that, we test password 123. This password includes uppercase letters, lowercase letters, numbers, and sufficient length. The result is still medium because symbols are missing. The program correctly identifies this and provides a single focus suggestion, which confirms that the feedback logic is precise and not repetitive. Finally, we enter password 123 and an exclamation mark. This password meets all the requirements: length, uppercase letters, lowercase letters, numbers, and symbols. The program classifies it as strong and displays a positive confirmation message without any suggestions. So now the password strength checker is fully functional, and you can experiment with your own inputs to better understand how the rules work together. That's it for this project. In this password strength checker, you built a simple but practical program that checks how strong a password is and explains why. Instead of just saying good or bad, the program looks at several rules and gives clear feedback that helps users understand how to improve their passwords. Through this project, you practiced several core Python concepts that are essential for beginners. You worked with user input to lead data from the keyboard, used conditional statements to make decisions, and applied a loop to keep the application running. You also organized logic into functions, used string methods to analyze characters, and learned how to return values and display clear output to the user. This kind of project shows how basic Python building blocks can come together to create something useful and realistic. Try changing the rules, adding new conditions, or testing your own ideas to make it even better. Great work! See you in the next lesson. Now let's zoom in on what we're actually going to build. This project is called Contact Book, and it's a simple but powerful program designed to help you keep track of people's details in one place. With it, you'll be able to add new contacts, see all of your saved contacts, search for someone quickly, and even delete contacts when you no longer need them. When you run the program, you'll see a clear menu in the console with numbered options. For example, you might type 1 to add a contact, enter the name Tom, his phone number, and email address. The program will confirm that the contact for Tom was added. You can then choose option 2 to view all contacts or option 3 to search for Tom and instantly see his details displayed. To make all this work, we're covering some essential Python concepts. You'll see how to define and use a class to model a contact, how to store multiple contacts as a list of objects, how to accept input from users, and how to control the flow of the program with loops and if-else statements. You'll also practice string methods like strip and lower to make the program more reliable. You're going to find that building a contact manager is a fun way to practice real-world coding skills. Stick with it, because by the end, you'll not only have a working app, but also a deeper understanding of how Python programs are structured. In the next step, we'll go through a step-by-step example to see exactly how each part of this program works. Okay, let's break down this code step by step. Instead of jumping straight into the full program, we're starting by creating a structure or template. Think of this as building the skeleton of our contact book first so we can clearly see where everything belongs before writing the actual logic. We begin with the contact class at the top. Right now, its methods are just placeholders. The constructor shows where we'll initialize the contact details, and the show_info method shows where we'll display them later. This helps us understand how each contact will be represented in our program. Next, inside the main function, we prepare our program to run. We display the contact book header and set up an empty list that will eventually store all our contact objects. Then we create a while loop that continuously displays a menu of options until the user decides to quit. Each option currently has a print statement saying what it will do once we add the real logic. The if-else structure below the input choice acts as the traffic controller of our program. Depending on the number the user enters, it will run the appropriate function. For now, each option just prints a message to remind us what will happen when we fill in the code later. By writing the entire structure first, we get a clear view of how the program flows from top to bottom. In the next step, we'll go back and replace each placeholder with real logic to add contacts, view them, search for a specific name, or delete an entry. This step-by-step approach keeps everything organized and much easier to follow as you build your own apps. Okay, let's take a look at them one by one. First, we're focusing on the class that powers the whole app. The idea is simple. Define a reusable blueprint called contact that knows how to hold one person's information and how to show it when we need it. We start with the class definition itself. Think of class as the word that tells Python, I'm creating a new type. The name is contact, written in Pascal case to make it clear it's a custom type. This class will represent a single entry in our contact book, a name, a phone number, and an email address. Inside the class, we place methods, the behaviors that every contact can do. Next comes the initializer, spelled with double underscores at the start and end. This special method runs automatically whenever we create a new contact. It receives 3 pieces of data, name, phone, and email, and stores them inside the object by assigning to self-name, self-phone, and self-email. From that moment on, the object remembers its own details. Let's keep attribute names clear and consistent because you'll reference them throughout the program. About self, it is Python's way of passing the actual object into its own methods. When you access self-name or self-email, you're talking to the specific contact in memory. You'll see self as the first parameter in every instance method. But when you call those methods later, you won't type self. Python supplies it for you. Finally, there's a small method whose job is to display one contact's information in a clean, readable line. It reaches into the object, pulls out the save fields using dot notation, and formats them neatly using a formatted string. Centralizing this print logic in one place keeps our code tidy. Elsewhere in the app, we can simply call the method on any contact to show it. That's the entire class section. A clear blueprint, an initializer that sets up the data, self to refer to the current object, and a method that knows how to present the details. With this in place, the rest of the program can create many contact objects, store them in a list, and work with them easily. Next, let's work on this option 1, add contact. This is where we actually collect the details for a new contact from the user and create a contact object. It's a key moment because we're moving from just having a class blueprint to actually building real objects and saving them in a list. The first 3 lines each use input to ask the user for a piece of information, name, phone, and email. After every input, we call .strip, which removes any accidental spaces the user might type at the start or end. This small step makes the program more reliable and prevents issues with matching names later. Once we've collected the 3 pieces of data, we create a new contact by calling our class like a function, passing in the name, phone, and email. This triggers the init method we wrote earlier, filling in all the details for that new object. Now we have a fully formed contact stored in the variable contact. Next, we use contacts append contact. This takes our new contact object and adds it to the contacts list we set up earlier. That list is like our mini database in memory. It holds every contact the user adds during the program's run. Finally, we print a confirmation message back to the user so they know their contact was successfully added. This small piece of feedback makes the app feel interactive and reassuring. With this section in place, the program can now take user input, create contact objects, and store them for later use. In the next step, we'll move on to writing the logic to view and search those contacts so we can make the app fully functional. Okay, let's take a look at this next part one by one. This section of the program runs when the user chooses option 2 from the menu. Its job is to show all the contacts that have been saved so far. The first line checks if there are any contacts stored. The condition if not contacts is Python's way of asking, is this list empty? If it is empty, we immediately print a friendly message telling the user that no contacts have been found. This gives clear feedback and prevents the program from trying to display something that isn't there. If the list isn't empty, the else block runs. We print a header line saying all contacts so the output looks neat and separated. Then we loop through the contacts list using proficient contacts. Here, each C represents one contact object that was added earlier. Inside the loop, we call c.show_info low. Because show_info is an instance method defined inside the contact class, it knows exactly how to display that contact's name, phone, and email in a clean, formatted way. This simple pattern, checking if the list is empty, printing a header, looping through the list, and calling an instance method, makes our program easy to understand and keeps the display logic in one place. In the next step, we'll handle searching and deleting, which will show how to make the app more interactive and complete. Okay, let's take a look at this next part one by one. This section runs when the user chooses option 3 from the menu. Its job is to let the user search for a contact by name and display the matching information. We start by asking the user to type in the name they're looking for. We immediately call strip and .lower on the input to remove any unwanted spaces and to make the search case insensitive. This means Alice and Alice will be treated as the same name, which makes the program friendlier. Next, we set a variable called found to false. This is a flag we'll use to track whether we found a matching contact during our search. Then we loop through the contacts list with proficient contacts. Each C is a contact object. Inside the loop, we compare c.name.lower to the search_name. Again, we use .lower on both sides to keep the comparison case insensitive. If the names match, we call c.show_info, which uses the method we defined in the contact class to print that contact's details. We also set found to true to record that we've successfully found a match. After the loop finishes, we check if found is still false. If it is, that means no contact matched the search name, so we print a message telling the user, contact not found. This section combines user input, string cleaning, looping, a conditional check, and an instance method to perform a simple but very useful search. In the next step, we'll move on to deleting a contact, which builds on the same ideas but removes an item instead of displaying it. Okay, let's take a look at this final part one by one. This section runs when the user chooses option 4 from the menu. Its job is to delete a contact from the list if it exists. We start by asking the user to type the name of the contact they want to delete. As before, we immediately call .strip and .lower on the input to remove any extra spaces and make the comparison case insensitive. This ensures that typing Alice or Alice will match the same contact. Then we loop through the contacts list with for C in contacts. For each contact object, we check if c.name.lower matches the del_name entered by the user. If it matches, we call contacts, remove C. This removes that specific contact object from the list. Immediately after that, we print a confirmation message telling the user that the contact has been deleted. We then use break to exit the loop so the program doesn't keep searching after a match has already been removed. If no matching contact is found, the loop finishes and the else block prints contact not found. This gives clear feedback to the user so they know nothing was deleted. This section combines everything we've practiced: cleaning input, looping through a list of objects, checking conditions, removing an object, and giving feedback to complete the core features of the contact book. At this point, the program can add, view, search, and delete contacts, making it a fully working console app. Okay, let's take a look at this last part one by one. This section runs when the user chooses option 5 from the menu. Its job is to gracefully exit the program. The code checks if the choice equals 5. If it does, the program prints goodbye as a friendly message to the user. Immediately after, it calls break, which stops the while loop that has been keeping the menu running. Breaking out of the loop ends the main function, and since there's nothing else after it, the whole program finishes. If the user types a number or character that doesn't match any option, the else block at the bottom runs instead. It prints invalid choice to tell the user they entered something outside the menu options, and the loop will then show the menu again. This final piece is important because it gives the user control to end the program cleanly at any time and handles mistakes without crashing. With this in place, the contact book is complete. You can add, view, search, delete, and quit safely, all from the console. Let's quickly run through how it looks. When you start the program, you see a clear header reading contact book and a numbered menu of options. You type 1 to add a contact. The program asks for a name, a phone number, and an email address. You enter Tom, his phone number, and his email address. The program immediately confirms that the contact for Tom has been added. The menu appears again. You choose one once more to add another contact. This time you enter Alice, her phone number, and her email address. Again, the program confirms that the contact for Alice has been added. The menu appears a third time. Now you type 2 to view all contacts. The program prints a neat header called All Contacts, then lists each saved contact on its own line, showing the name, phone, and email. In this example, you see Tom's details first and Alice's details right after. This is how the app behaves from the user's point of view. You select an option, provide the information when prompted, and the program responds instantly with clear, formatted output. After viewing all contacts, the menu appears again. This time you type 3 to search for a contact. The program asks you to enter the name you want to search for. You type Alice. The program goes through the saved contacts, finds a match, and immediately displays Alice's details in a clean, formatted line showing her name, phone number, and email address. From the user's point of view, this feels smooth and instant. You choose the search option, type the name, and the program brings up the exact contact details without any extra steps. After successfully searching for Alice, the menu appears again. This time you type 4 to delete a contact. The program asks for the name you want to delete and you enter Alice. It finds the matching contact, removes it from the list, and immediately prints a confirmation message saying that the contact for Alice has been deleted. The menu then reappears. You type 2 to view all contacts again. The program prints the all contacts header and now shows only Tom's details, confirming that Alice has been removed from the list. From the user's point of view, it feels clear and responsive. You select delete, type the name, get instant feedback, and then verify by viewing the updated contacts list. After checking that only Tom remains in the contact list, the menu appears one last time. This time you type 5 to quit. The program immediately prints a friendly goodbye message and stops running. From the user's perspective, it ends cleanly and predictably. You can add, view, search, delete contacts, and when you're done, exit the program smoothly with a simple menu choice. Okay, let's take a look at how the contact book deals with mistakes or empty situations. One of the reasons this program feels smooth is because it anticipates what might go wrong and gives the user clear feedback instead of crashing. When you choose option 2 to view all contacts but the list is empty, the program doesn't try to loop through nothing. Instead, it checks first and prints no contacts found. This prevents an error and lets the user know exactly what's happening. When you try option 3 to search for a name that isn't in the list, the program loops through all the contacts, sees that there's no match, and then prints contact not found. This is much friendlier than just showing nothing because it confirms that your search ran, but no results came back. The same idea applies to deleting a contact. If you type option 4 and enter a name that isn't there, the program again reports contact not found. This tells the user nothing was removed and that they might have mistyped or need to add the contact first. Finally, if you type an option outside the menu range, like 6, the program prints invalid choice and re-shows the menu. This keeps the program running and guides the user back to valid options. All of these checks are simple but powerful. They make sure the program behaves predictably, stays user-friendly, and helps you understand what went wrong so you can fix it. That's it for this project. You've just built a simple but powerful contact book application that lets you add, view, search for, and delete contacts all from the console. It works like a tiny personal database, making it easy to practice real-world coding skills in a small, manageable project. This project demonstrates some of the most important Python concepts for beginners. You've worked with classes to define a blueprint for contacts, lists to store multiple objects, input to collect information from the user, and loops and conditionals to navigate the menu and handle different choices. You also saw how string methods like strip and lower can make a program more robust and user-friendly. Great work today. Take a moment to experiment with this program. Add more features, change the layout, or practice with different inputs, and see how far you can take it. See you in the next lesson.